Right now, under South America, there is a hole in Earth's shield, not a metaphor, a real gap in the planet's magnetic field, wide enough to knock out satellites passing through it, and it is splitting in two. Beneath your feet, the ground is humming, a steady, low note playing non-stop with no confirmed source. Scientists have caught it on land, caught it underwater, and still cannot fully explain it. Deep inside the core, a ball of iron the size of Pluto might be spinning backward. Under Antarctica's ice, lakes have stayed sealed off from daylight for millions of years, and something is alive in them. Somewhere over a storm tonight, a ball of light might flicker into existence, hover, and vanish. Breaking rules physicists thought they understood. We think of Earth as finished, mapped, solved. But under the surface, in the sky above storms, in ice sheets, and in the spinning core, our planet is behaving in ways that do not match the textbooks. If you're enjoying strange, true stories about the world we live on, hit like and subscribe so more of this finds you. Get ready. We start at the crack in Earth's shield. A satellite passes over South America, and its computer starts to glitch. This happens all the time, in the exact same patch of sky. Engineers have a name for it. They call it the South Atlantic Anomaly. It sits over Brazil and stretches across the ocean toward Africa, and inside that zone, Earth's magnetic field is weaker than anywhere else on the planet. Here's why that matters. Earth's magnetic field acts like a shield. It stretches far past the surface, out into space, and it blocks charged particles blasting off the sun. Without it, those particles would slam straight into satellites, into spacecraft, even into us. But over this one patch of the southern hemisphere, the shield thins out. Radiation dips closer to the surface than anywhere else on Earth. Satellites flying through it get hit with a dose of particles strong enough to scramble onboard computers, sometimes forcing engineers to shut systems down until the spacecraft clears the zone. Picture it like a force field with a soft spot. The rest of the shield holds strong, but right there, over one section of ocean, it thins out, like a sheet of ice on a lake that never quite freezes solid. The strange part is not that the weak spot exists. Scientists have tracked it since the 1800s. The strange part is what it's doing now. Satellite data going back to 2014 shows this anomaly is expanding. It has grown by an area roughly half the size of continental Europe in about a decade. And its lowest point, the spot where the magnetic field is at its weakest, keeps sliding westward, drifting further out over the ocean year after year. Space agencies are not panicking, they are watching. NASA scientists track this zone constantly, feeding new satellite readings into computer models that try to predict where the anomaly will sit 5 years from now, 10 years from now. That prediction matters, because more and more of our technology depends on satellites passing safely through space. GPS, weather forecasting, internet signals bounced off orbit. Every one of those systems has hardware that has to survive a trip through this weak patch in the shield. Down on the surface, you would never know any of this is happening. No storms, no warning signs in the sky. The anomaly leaves no mark you could see with your own eyes. It only shows up in the data, in radiation counters, in satellites reporting strange errors from the exact same coordinates, over and over. That's what makes it unsettling. A weak point in the thing protecting our entire planet from the sun, growing quietly, and almost nobody on the surface has ever heard of it. Scientists know the shield is thinning here. They do not fully agree on why. Some point to strange rock formations sitting deep underground, over 1,000 miles down, messing with the magnetic field from below. Others point to shifts happening in the molten metal at Earth's very core, because to understand why the shield has a hole in it, you have to go deeper, past the crust, past the mantle, down to the churning iron core that builds Earth's magnetic field in the first place. And that's where things get even stranger. In 2020, NASA scientists studying the weak spot noticed something that made them look twice. The anomaly wasn't just one dent in the magnetic field anymore. It was becoming two, Picture a single low valley in the ground, slowly stretching until a ridge rises up in the middle, splitting it into two separate basins. That's roughly what satellite data has shown happening to the South Atlantic anomaly. What used to be one connected zone of weak magnetic field is dividing into two distinct centers, one drifting towards South America, one drifting towards Southern Africa, and the two halves are not behaving the same way. Researchers studying the split found that the field is weakening faster on the African side than on the South American side. The two halves of the same anomaly are diverging, changing at different speeds, like two branches of a crack spreading apart at uneven rates. One geomagnetism professor working with satellite data described it simply: something specific is happening in this region that is making the field weaken more intensely than expected. To understand why, scientists had to look at what's happening far below the surface, at the boundary between Earth's molten outer core and the solid rock of the mantle above it, nearly 2,000 miles down. Normally, magnetic field lines flow outward from the core in a predictable way, but underneath the anomaly, researchers found patches where the field lines are doing the opposite. Instead of flowing out, they curve back down into the core, like water flowing backward against a strong current. These are called reverse flux patches, and satellite data shows at least one of them slowly drifting westward beneath Africa, dragging part of the weak zone along with it. This is the same technology that lets scientists track hurricanes and glaciers from orbit, only pointed nearly 2,000 miles straight down into the hidden heart of the planet. Nobody on Earth's surface has ever seen the outer core. Nobody ever will. It's a shell of liquid iron and nickel, thousands of miles thick, spinning and churning far below our feet. But its motion is exactly what generates Earth's entire magnetic field in the first place, through a process scientists call the geodynamo. That means every ripple, every eddy, every strange current down there eventually shows up as a change in the field we measure from space. The anomaly splitting in two is not a random glitch. It's a message carried nearly 2,000 miles through solid rock, telling scientists that something in the churning core beneath us is shifting in a way our models did not fully predict. Satellites will keep watching the split for years to come, tracking whether the two halves merge back together, drift further apart, or do something nobody has modeled at all. But the core isn't just leaking strange signals into the magnetic field. Some scientists now believe a piece of the core itself may be doing something even harder to explain. Something spinning in the wrong direction. Nearly 2,000 miles beneath Africa sits something the size of a continent, and scientists still argue over what it actually is. It's called a large, low-shear velocity province. That's a mouthful, so picture it a simpler way. Seismic waves from earthquakes travel through the deep earth at predictable speeds, the same way sound moves faster or slower depending on what it's passing through. But when waves pass through this one region near the core, they slow down, dragging like a runner hitting mud instead of pavement. That slowdown tells scientists something down there is denser, hotter, or chemically different from the rock around it. A massive, buried structure, roughly the size of a continent, sitting right at the boundary between Earth's rocky mantle and its molten core. There are two of these giant structures on opposite sides of the planet, one under Africa, one under the Pacific Ocean, almost mirroring each other. Nobody has ever touched this structure. Nobody ever will. It sits under thousands of miles of solid rock, far beyond any drill humans have ever built. Everything scientists know about it comes from listening, the same way a doctor reads an ultrasound without ever opening the body. Here's where it connects back to the crack in Earth's shield. Researchers studying the South Atlantic anomaly found that this buried African structure sits almost directly beneath the weakest point in our planet's magnetic field. That is not likely a coincidence. The blob appears to disturb the flow of molten iron in the outer core above it, the same churning metal that generates Earth's entire magnetic field in the first place. Disturb the flow, and you disturb the field it creates, thousands of miles above. Think of it like a boulder sitting at the bottom of a fast-moving river. The water above the boulder swirls differently than water flowing over a smooth riverbed. Multiply that by thousands of miles, and a few degrees of extra density in solid rock, and you get a warped magnetic field bleeding out into space. Scientists still debate what this buried structure is actually made of. Some think it could be the remains of an ancient ocean floor, dragged down into the deep earth over hundreds of millions of years by shifting tectonic plates. Others think it might be leftover material from the violent collision that formed the moon, sinking to the bottom of Earth's mantle billions of years ago and staying there ever since, like sediment settling at the bottom of a lake and never disturbed again. There's no way to test either idea directly. No drill on Earth has ever gone deeper than about 7.5 miles, barely scratching the surface of a mantle that stretches down nearly 1,800 miles. So this structure remains one of the largest, strangest objects on our planet, and it will likely stay a mystery for the rest of our lives. But the closer scientists look at the boundary between mantle and core, the more they realize this buried structure isn't the only thing acting strange down there. The core itself is doing something even harder to explain. Picture a solid iron sphere, about 70% the size of the moon, buried 3,200 miles beneath your feet. Now, picture that sphere slowly stopping and starting to turn backward. That is what a team of scientists at the University of Southern California believes is happening right now, inside Earth's inner core. Nobody can drill down and watch this directly. Instead, scientists use something almost poetic: earthquakes. When two earthquakes strike from nearly the same spot, years apart, they send nearly identical seismic waves rippling through the planet. If the inner core were frozen in place, those waves would arrive looking exactly the same each time. But researchers found the waves kept arriving slightly different, shifting bit by bit, year after year. That shift is a fingerprint of motion. It means the inner core is rotating at a different speed than the rest of the planet around it. For decades, most scientists believed the inner core spun slightly faster than Earth's crust and mantle, like a spinning top nested inside a slightly slower outer shell. But a study published in the journal Nature tracked over 100 pairs of matching earthquakes from the South Sandwich Islands, spanning more than 3 decades, and found the core's extra speed had vanished. Around 2010, it slowed to match the rest of the planet. Then it kept slowing until it appeared to be trailing behind, drifting backward relative to the surface. One of the lead researchers put it simply. He said, "We've been arguing about this for 20 years, and this evidence nails it down. Here's a comparison that helps. Imagine 2 runners on a circular track, one on the inside lane, one on the outside. For decades, the inside runner, the core, ran slightly faster, slowly lapping ahead. Then it slowed to match pace. Then it started falling behind, drifting backward relative to the runner beside it. That backward drift is exactly what scientists are now seeing in the deep Earth. The researchers believe this isn't random. It appears to follow a cycle roughly 70 years long, swinging from superfast to matched pace to backward drift, and eventually swinging forward again. If that cycle is real, the core likely made this same backward shift once before, sometime in the 1970s, and nobody on the surface ever noticed a thing. Scientists suspect the swirling liquid metal of the outer core and the immense pressure of the mantle pressing down from above are both tugging on the solid inner core like invisible hands, nudging its spin one way, then the other, over the span of decades. What does any of this mean for us on the surface? Almost nothing. Day to day, you will never feel this shift, but the inner core's motion is tangled up with the outer core's churning, and that churning is exactly what generates Earth's magnetic field. A ball of iron drifting backward, 3,200 miles beneath your house, connects in ways scientists are only beginning to trace, all the way up to the crack in the shield above South America. And this isn't the only signal leaking up from the deep Earth that nobody has fully explained. There's also the sound. Right now, as you listen to this, the ground beneath you is humming a note you cannot hear. Scientists call it Earth's free oscillation, and here is the strange part. For most of history, researchers believed only massive earthquakes could make the entire planet ring like a bell. A huge quake would send shockwaves through the Earth, and the whole planet would vibrate afterward, the same way a struck bell keeps ringing after the hit. But in the 1990s, seismologists picked up something they did not expect. The hum was there constantly, even on days with no major earthquakes anywhere on Earth. A steady, ultra-low vibration playing non-stop, whether anything shook the ground or not. Imagine holding a giant bell that never stops ringing, even though nobody ever struck it. That's essentially what researchers discovered when they pointed sensitive instruments at a perfectly calm, quiet stretch of days. For decades, the leading explanation involved the ocean, waves rolling across the surface, crashing against continents, pressing down on the seafloor with constant, rhythmic force, day and night, everywhere on Earth at once. That relentless pressure, scientists theorized, could be enough to set the whole solid planet gently vibrating, like a giant drumhead being tapped by billions of soft fingers at once. For years, this idea remained just that, a theory. Because there was a problem, nearly every seismometer capturing the hum sat on dry land. 70% of Earth is covered by ocean, and researchers had almost no way to record the hum from underneath the waves themselves, right where the theory said the source should be strongest. Then, in an expedition to the floor of the Indian Ocean, scientists placed specialized spherical seismometers directly on the seabed, and for the first time in history, they recorded Earth's hum from underwater. It confirmed the hum truly exists everywhere, land and sea. But it did not settle the debate. Researchers still argue over the exact mechanism. Some believe it's ocean waves colliding with each other in specific patterns out at sea, sending energy downward through the water into the crust. Others believe it comes from waves interacting directly with the seafloor near coastlines. Some think the atmosphere itself plays a role, with shifting air pressure adding its own contribution to the mix. Here's why any of this matters to you. This hum is not just a curiosity. It offers scientists a completely new way to study the deep interior of the planet. Earthquakes are rare, violent, and unpredictable, like a single flashlight beam briefly illuminating a dark room. But the hum is constant, always there, always available. If scientists can fully decode it, they gain a steady, permanent signal for mapping the hidden structure of the Earth, the very same structure that includes that mysterious blob beneath Africa and the shifting inner core 3,000 miles down. A seismologist at Columbia University once put it simply. He said the Earth is ringing like a bell all the time, and it's not just seismometers picking up strange sounds nobody can fully explain. Some people say they can hear something too, with their own two ears. In towns scattered across the world, a small number of people report hearing something nobody else around them can hear. A deep, constant humming or droning sound, with no obvious source. It has different names depending on where you are. The Taos hum in New Mexico, the Auckland hum in New Zealand, the Windsor hum near the Canadian border. Reports have come in from Canada, Australia, South Africa, Norway, and cities across Europe. A teacher in Canada eventually built an online database just to collect these accounts from around the world, and it now holds thousands of reports from people convinced they are hearing something real. Scientists estimate somewhere between 2 and 4% of people worldwide experience this. That means if you filled a school gym with 200 people, as many as 8 of them might swear they hear a humming sound the rest of the room cannot detect at all. For years, researchers chased this mystery down 2 possible paths. First, maybe hearers have unusually sensitive ears, able to pick up real low-frequency sounds that everyone else's ears simply filter out. Second, maybe there's a physical sound source out there, something environmental, something mechanical, something nobody has pinpointed yet. A recent study tested both ideas directly, and neither one fully explained what people were experiencing. Most hearers did not show exceptional, low-frequency hearing on standard tests, and researchers could not consistently detect any outside physical sound source matching what people described. Instead, The strongest lead pointed somewhere unexpected, inside the ear itself. Deep inside your inner ear sits a tiny spiral structure called the cochlea, and it doesn't just receive sound, it can actually generate faint sounds of its own, a natural byproduct of how your ear amplifies incoming noise. Most people never notice these self-generated sounds, but researchers now believe that for some people, these internal sounds may be perceived as an external hum, essentially a form of low-frequency tinnitus that feels like it's coming from outside the body, even though it's being generated inside the ear. One researcher explained it carefully. He said that although they haven't ruled out every possible outside sound source, the evidence increasingly points towards something happening inside the auditory system itself. Here's a comparison that helps. Imagine standing in a perfectly silent room and still hearing a faint ringing, the same ringing you'd get right after a loud concert. Except for hum hearers, that internal ringing might never fully fade, and their brain interprets it as a real sound drifting in from somewhere outside. This doesn't make the experience any less real for the people living with it. Scientists admit there is still a great deal they don't understand about how the human ear processes very low-frequency sound. Most hearing research has focused on the higher pitches we use for speech and music, leaving this deep, murky end of the sound spectrum surprisingly unexplored. So somewhere between the hum of the entire planet vibrating in the deep earth and a hum some people hear inside their own skulls, science is still chasing two mysteries that sound almost identical, and connecting them may take years. But not every strange hum stays a mystery forever. Sometimes, if you listen closely enough, a hum can lead you straight to something being born. In November 2018, seismometers on every continent picked up something nobody could identify. A strange, steady hum, ringing out at a single frequency, traveling around the entire planet. It reached Kenya, it reached Chile, it reached Canada and Hawaii. Some of these signals lasted up to 20 minutes at a time, and over 400 of them were recorded in total. Normal earthquakes send out a chaotic mix of frequencies, sharp and jagged, like a drum being struck. This was different, smooth, steady, almost musical. Seismologists had never seen anything quite like it, and it got stranger. Real earthquakes produce specific types of shockwaves that people can physically feel, sharp jolts called P waves and S waves. This event barely produced any, no shaking, no damage, just this long, low, ringing hum sweeping silently through solid rock all the way around the globe. The source traced back to a tiny island called Mayotte, sitting in the Indian Ocean between Madagascar and Mozambique. For months before the hum, residents there had felt something unusual. Over 1,000 small earthquakes rattled the island almost daily, including one of the strongest quakes ever recorded in the region. People were frightened enough to sleep outdoors in open fields rather than risk staying inside their homes. Scientists scrambled to explain it. Some early theories suggested a magma chamber draining out somewhere beneath the seafloor, but without local monitoring equipment near the island itself, researchers were stuck piecing together clues from seismic stations scattered thousands of miles away, like trying to diagnose an illness using only echoes bounced off distant walls. Then, in 2019, a research ship sailed out to the waters near Mayotte to investigate directly. What they found stunned them. A brand new volcano, sitting on the ocean floor, roughly half a mile tall, taller than the Empire State Building, and over 3 miles wide. It had not existed before. It had grown from nothing, entirely underwater, in less than a year. Researchers eventually pieced together the full story. Deep beneath the island sat a massive underground reservoir of molten rock, 9 miles wide, buried in the upper mantle. Sometime in 2018, that magma began pushing upward, forcing its way through miles of solid crust. As it moved, it triggered thousands of small earthquakes along its path, like a drill boring slowly through rock, each grinding step registering as a tiny tremor. Finally, the magma broke through the ocean floor, and that final release, an eruption so massive that scientists later called it possibly the largest ever detected happening underwater, is what sent that strange, steady hum rippling silently around the entire Earth. An earthquake expert not involved in the discovery said something important afterward. He said that without that dramatic hum, scientists probably never would have found the volcano at all. Think about that for a second. A brand new mountain, taller than a skyscraper, was built on our planet in under a year, and the only reason we know it happened is because the whole Earth rang like a bell to announce it. This is what makes Earth's hums worth taking seriously. Sometimes they're background noise scientists still can't fully explain. But sometimes, if you listen closely enough, they're the sound of the planet building something new, right under our feet, in real time. And the deep Earth isn't the only place sending Earth's surface unexpected signals. Above us, the atmosphere itself is doing something almost nobody notices. And the reason we ever found out is almost as strange as the phenomenon itself. Every compass on Earth is pointing at a moving target, and it has been sprinting for the last 30 years. Most of us learned in school that the North Pole sits in one fixed spot, frozen at the top of the world forever. That's true for the geographic pole, the exact point where Earth's spin axis meets the surface. But the magnetic North Pole, the point every compass actually points toward, is not fixed at all. It wanders year after year, and lately it has been moving faster than almost anyone predicted. When explorer James Clark Ross first measured its location back in 1831, magnetic north sat in the icy islands of northern Canada. For over a century and a half, it crept along slowly, drifting less than 10 miles a year, barely noticeable across a human lifetime. Then, sometime around the 1990s, it hit the gas. Its speed jumped to as much as 37 miles a year, a change so sudden that scientists still don't fully agree on exactly what triggered the shift. Picture a marble resting near the center of a shallow bowl, barely rolling for over 100 years. Then, without warning, someone tilts the bowl, and the marble takes off rolling toward one edge. That sudden shift in speed is roughly what happened to the pole in the 90s, and researchers are still working out exactly what tilted the bowl. Today, the magnetic North Pole has crossed into the central Arctic Ocean, in territory modern instruments have never recorded it occupying before. It is now officially closer to Siberia than to Canada, a milestone after nearly 2 centuries of continuous drift. Here's why this matters far beyond geography class. The exact location of magnetic north feeds directly into something called the World Magnetic Model, the official reference used by military aircraft, naval submarines, commercial shipping lanes, and even the compass app on your phone. Every GPS system on the planet leans on this model staying accurate. If the pole drifts too far without an update, navigation errors start creeping in quietly, the kind of small miscalculation that can throw a flight path off course or send a ship the wrong direction by a few crucial degrees. So what's actually driving this sprint? Scientists trace it back to the same churning outer core that builds Earth's entire magnetic field. Satellite data collected over 2 decades reveals something like a tug-of-war happening nearly 1,800 miles beneath the Arctic, between 2 massive underground patches of magnetic force, one centered under Canada, one under Siberia. For most of the 20th century, the Canadian patch held the advantage, keeping the pole anchored nearby. But researchers found that changes in the flow of molten metal between 1,970 and 1,999 stretched and weakened that Canadian patch, loosening its grip. As it weakened, the Siberian patch effectively started winning the tug-of-war, dragging the pole steadily east. Recently, the pole's blistering pace has actually slowed down again, from that frantic 37 miles a year down closer to 20. Scientists studying the deep core call this the largest deceleration in pole speed ever measured. Nobody knows yet if this is a temporary pause or a sign the tug-of-war beneath the Arctic is shifting yet again. One geomagnetic researcher put it simply. He said it could speed back up or it could keep slowing down, and right now, the only honest answer is that we're watching in real time. The pole racing across the Arctic is proof that Earth's magnetic field is a living, moving system, reshaping itself from thousands of miles below, whether we notice from the surface or not. And the same restless planet, capable of moving an entire magnetic pole across an ocean, is also lobbing rocks at us from space, in patterns nobody predicted either. For 23 days in March of 2026, something kept blasting through the sky over the United States and Europe, and scientists are still working out exactly why. It started on March 17, over Cleveland, Ohio. A chunk of rock, roughly 6 feet across, weighing about 7 tons, screamed into the atmosphere at 45,000 miles an hour. That's fast enough to cross the entire state of Ohio in under 2 minutes. It broke apart high above the city, sending a sonic boom rolling across Cleveland and into Pennsylvania, rattling windows and shaking homes. People ran outside, thinking something nearby had exploded. There was no storm in the sky, no clouds anywhere, just a sudden, chest-thumping boom out of a clear blue afternoon. 4 days later, it happened again, this time over Houston, Texas. A smaller rock, roughly the size of a basketball, but weighing about a ton, broke apart 29 miles above the city, releasing energy equal to roughly 26 tons of TNT. A dark fragment tore through the roof of a home in a Houston suburb and landed inside, like the sky itself had thrown a rock through someone's bedroom window. Before that month ended, more fireballs lit up the sky over California, Arizona, Nevada, Louisiana, and southern Illinois, along with a massive daylight explosion over Western Europe that generated over 3,000 eyewitness reports on its own. Here's the number that got scientists paying close attention. The American Meteor Society tracks these events every year, and March 2026 averaged nearly 143 witness reports per event. Compare that to the next highest March ever recorded, back in 2021, which averaged less than 50. Nearly 3 times the normal rate, in a single month, with no major meteor shower scheduled anywhere near that stretch of the calendar. So naturally, people online started asking the obvious question, was something else going on? Scientists were quick and direct in their answer. Every single fireball with enough data to calculate a path traced back to an ordinary orbit around the Sun, material that has been drifting through our solar system for billions of years, occasionally crossing paths with Earth, exactly the way physics predicts it should. Researchers even recovered physical pieces of 2 of these rocks. The Ohio meteorite and a fragment from the European fireball both turned out to be a rare type called chondrites. Fragments blasted off a large asteroid called Vesta, sometime in the ancient past, then drifting through space for over 4 billion years before finally colliding with our planet in the same single month. What scientists still can't fully explain is why so many large, bright fireballs arrived in such a short window, all producing loud, audible booms at an unusually high rate. Most fireballs are silent streaks, gone in a second, with no ground-level sound at all. This batch was different, violent enough on entry to blast shockwaves all the way down to the surface, again and again, city after city. And there was another uncomfortable detail buried in the aftermath. When the Ohio rock exploded, the region's dedicated all-sky meteor camera happened to be offline. Scientists had to reconstruct the entire event using scattered eyewitness videos and doorbell cameras instead of dedicated instruments. It's a reminder that even now, in an age of satellites circling the entire planet, our system for tracking incoming space rock still has real gaps. Space rock exploding over cities is dramatic enough on its own, but some things falling out of the sky don't explode instantly. Some of them hover, glow, and float, defying rules of physics scientists still argue over today. Picture a thunderstorm rolling over your neighborhood, rain hammering the windows, lightning cracking overhead. Then, drifting silently through the air, a glowing ball of light appears out of nowhere. It floats. It hovers. Sometimes it passes straight through a closed window without shattering the glass, then vanishes a few seconds later, sometimes with a loud pop, sometimes without a sound at all. This is ball lightning, and people have been reporting it for centuries. It shows up in pilot logs, house fires, cockpit sightings, and hundreds of documented cases every year in the United States alone. And after nearly 200 years of study, physicists still cannot fully explain what it actually is. Here's what makes it so strange. Ball lightning isn't just an especially bright flash of regular lightning. It behaves completely differently. Regular lightning is a fast, branching streak of electricity, gone in a fraction of a second. Ball lightning is a glowing, compact sphere, usually somewhere between the size of a golf ball and a beach ball, that can hover, drift, or roll for several seconds, sometimes even close to a minute, before disappearing. Think about a soap bubble drifting across a room, glowing from the inside like a light bulb, moving at walking pace, then popping without warning. That's roughly the visual people describe, except this bubble sometimes rolls straight through solid glass without leaving a mark. That detail alone has wrecked most of the leading scientific explanations. Researchers have proposed that ball lightning might be a pocket of hot, glowing gas, similar to a small flame, but hot gas rises, and most ball lightning sightings describe it drifting sideways or hovering steady, not floating upward like smoke. Others proposed it might be a bubble of trapped plasma, ionized gas similar to what powers a neon sign, held together by intense microwave energy left over from a nearby lightning strike. That theory explains some features nicely, but struggles to explain how the glowing ball can pass straight through a solid window without disturbing it. One physicist studying the mystery put it bluntly. He said the failure to explain ball lightning doesn't come down to small missing details. The basic size, the basic power output, the basic timing, and the way it passes through solid barriers have defeated essentially every model proposed so far. Some researchers have managed to create small, glowing, short-lived orbs in laboratory conditions, using electrical discharges through certain metals, or controlled combustion of fine dust particles in the air. These lab-made balls of light do resemble parts of what witnesses describe, but none of them fully match every property of the real thing, especially that strange ability to glide through solid glass and leave it completely undamaged. So ball lightning remains one of those rare cases in modern science where something is undeniably real, witnessed by thousands of credible people, including pilots and scientists themselves, and still cannot be fully recreated or explained. It sits in a strange category, one small step away from being fully understood, yet still slipping through every theory scientists throw at it, the same way it apparently slips through glass. And ball lightning isn't the only glowing mystery lurking around thunderstorms. Above the clouds, storms are launching something even stranger straight up toward the edge of space, and almost nobody on the ground ever notices. In 1989, a team of scientists in Minnesota was testing a camera meant for an upcoming rocket launch. They pointed it at the night sky, not expecting to capture anything unusual. By accident, they filmed something that changed atmospheric science forever. A massive, reddish burst of light, flickering above a distant thunderstorm, stretching upward instead of down toward the ground. It lasted only a fraction of a second. Scientists eventually named it a sprite, and it turned out to be just the first of an entire hidden category of lightning that nobody had properly documented before. Here's what makes sprites so strange. Regular lightning strikes downward, toward the ground, releasing energy in a jagged, branching bolt you can watch from your backyard. Sprites do the opposite. They erupt upward from the very top of a thunderstorm, reaching into a layer of the atmosphere called the mesosphere, roughly 50 miles above the surface. That's higher than the layer where commercial jets fly, higher than weather balloons can reach. Right at the edge, where our atmosphere starts thinning into space itself, picture a jellyfish flipped upside down, its tendrils reaching upward instead of trailing below, glowing bright red for a fraction of a second, then vanishing completely. That's roughly what a sprite looks like. And the entire event is often over in about 10 milliseconds. Faster than a single blink. Sprites are not the only member of this hidden family. Scientists later documented blue jets, narrow columns of blue and violet light that shoot upward from storm tops at incredible speed, sometimes punching all the way into the stratosphere. Unlike the flickering, jellyfish-shaped sprites, blue jets look more like a single beam of light, launched straight up like a rocket, gone in an instant. For decades, these events were almost mythical. Pilots reported strange flashes above storms going back over a century, but without proof, most scientists dismissed the accounts as tricks of the eye or reflections off clouds. It took accidental camera footage, then astronauts pointing specialized instruments down at Earth from the International Space Station, to finally confirm these events were real and document them in real detail. That's part of what makes this discovery so remarkable. We had been living underneath these storms for our entire history as a species, and we only recently realized there was an entire hidden light show happening directly above our heads, virtually every single day, somewhere on the planet. Scientists still don't fully understand what triggers a storm to produce a sprite or blue jet instead of ordinary lightning. Some storms create dozens of these events. Others, seemingly just as powerful, create none at all. Researchers are also studying whether these upper atmosphere flashes connect to gravity waves, ripples of energy that travel silently through the upper atmosphere, similar to ripples spreading across a pond after a stone drops in. What we do know is that these flashes are not just cosmic decoration. They appear to genuinely affect the chemistry of the upper atmosphere, and researchers believe understanding them better could improve aviation safety and storm forecasting. An entire electrical world exists above every thunderstorm on Earth, invisible from the ground, discovered mostly by accident, and still only partly understood. And storms are far from the only place on this planet hiding things science stumbled onto by chance. Beneath one of the coldest, most desolate places on Earth, scientists found something even harder to explain, sealed away in complete darkness for millions of years. Beneath more than 2 miles of solid Antarctic ice, hidden from every trace of sunlight, sits a lake roughly the size of Lake Ontario. It's called Lake Vostok, and for at least 15 million years, it has been completely sealed off from the rest of the planet. No sunlight has touched its surface since long before the first humans ever existed. No fresh air, no contact with our atmosphere at all, just total darkness, crushing pressure, and near freezing water, trapped under an ice sheet nearly 2 miles thick, roughly the height of 7 Empire State Buildings stacked on top of each other. Scientists first detected the lake in the 1990s using radar that could see straight through the ice, similar to how a doctor uses an ultrasound to see inside a body without cutting it open. But detecting the lake and actually reaching it were two very different challenges. It took a Russian team more than 2 decades of careful drilling before they finally broke through in February of 2012. Here's a comparison that captures the scale of the difficulty. Imagine trying to drill precisely through 2 miles of solid ice, careful enough not to disturb an ancient, untouched ecosystem below, while working in one of the coldest, most remote places on the surface of the Earth. The drilling took so long, moving only a few hundred meters each season, that the ice cores they pulled up along the way ended up preserving Earth's own climate record, trapped air bubbles stretching back more than 400,000 years. When the drill finally punched through, the pressure inside the lake was so intense that water shot straight up the borehole and froze solid before scientists could even lower an instrument down to study it. Researchers had to wait until the following season, then carefully analyze that frozen plug of lake water instead. What they found stunned them. Genetic material from thousands of distinct biological sequences, evidence of life that had been evolving in complete isolation, in total darkness, for millions of generations. Most of the traces belonged to bacteria, but researchers also found evidence linked to more complex organisms, and even genetic material connected to species, usually found near deep-sea hydrothermal vents, hinting that similar heat sources might exist at the bottom of Lake Vostok itself. keeping the water from freezing solid despite the extreme cold above. Scientists still debate exactly how life first got into the lake, since it has been completely cut off from open air and sunlight for so long. The leading idea is that life took hold before the lake was ever sealed, back when parts of the region were still exposed, then slowly adapted generation after generation as the ice closed in overhead, transforming an ordinary ecosystem into something built entirely for permanent darkness. This isn't just a curiosity about one hidden Antarctic lake. Researchers consider Lake Vostok a close analogue for what might exist on other worlds, like the ice-covered oceans hidden beneath the frozen crusts of Jupiter's moon Europa or Saturn's moon Enceladus. One scientist involved in the drilling expedition described it perfectly. He said it felt like exploring another planet, except this one happens to be our own. Life finding a way to survive in one of the darkest, most crushed, most isolated places on Earth is remarkable enough on its own. But Lake Vostok isn't even the most extreme example. Even deeper, below the surface, scientists have found something surviving in conditions that make this frozen lake look almost comfortable by comparison. Beneath the ocean floor, buried in layers of ancient mud, scientists found something that seems to break the basic rules of biology. Microbes so slow, so starved of energy, that some of them may only reproduce once every few thousand years. Compare that to the bacteria in your own gut, which can double their entire population in about 20 minutes. Now imagine an organism so slow that a single generation, birth to reproduction, could stretch longer than the entire span of recorded human history. That's not an exaggeration. Researchers studying sediment drilled from the deep sea floor calculated average generation times for some of these microbial communities in the thousands of years, and in the most extreme, energy-starved layers, potentially far longer than that. Here's why this matters. Scientists have known for over a decade that beneath the ocean floor lies one of the largest ecosystems on the entire planet, a hidden layer of microbial life buried in sediment that stretches for miles in every direction, in some places extending over 1.5 miles beneath the seabed. Researchers call it the deep biosphere, and by total number of living cells, it may rival or even exceed every plant, animal, and human combined on the surface of the Earth. Down there, conditions are brutal. No sunlight ever reaches this deep. Food is almost non-existent, filtering down over millions of years as scraps of organic material slowly buried under layer after layer of sediment. And yet, against all odds, these microbes are still alive, clinging to an existence so slow and so quiet it barely registers as living at all. Picture a marathon runner forced to take one single step every few hundred years, conserving every ounce of energy just to remain standing, never sprinting, barely moving, yet somehow never collapsing either. That's roughly the pace of life scientists are describing when they study these deep sediment microbes. Some researchers describe this state as physiological standby, cells that appear technically alive, still capable of basic maintenance and repair, but functioning at such an extremely reduced rate that traditional definitions of growth and reproduction barely apply. One study described the situation plainly. Researchers said this longevity is such a strange property of the deep biosphere that it is genuinely difficult to reconcile with our basic understanding of how life is supposed to work. And it gets stranger. In certain deep, extremely hot regions of the seafloor, temperatures soar past the boiling point of water. Over 200 degrees Fahrenheit, conditions researchers once assumed would completely sterilize any buried sediment. Instead, scientists recently found active microbial communities thriving there too, this time running their metabolism at surprisingly high speed, similar to organisms living on the surface, apparently spending most of their energy simply repairing the constant damage caused by that extreme heat. So somewhere beneath the seafloor, life exists on two wildly different extremes at once. In the cold, energy-starved layers, some organisms creep along so slowly, their next reproduction might not happen in your lifetime, or your grandchildren's lifetime either. In the hottest, most crushed layers. Other organisms burn through energy at nearly normal speed, just to survive being cooked alive from below. Nobody fully understands how either extreme is possible, biologically speaking, and that mystery connects to something even bigger hiding beneath our feet, a hidden layer of life so vast it may outweigh everything living on the surface combined. Deep beneath the surface, packed inside solid rock and buried ocean sediment, sits a hidden world of life, larger than most people could ever imagine. Scientists spent 10 years trying to measure it. An international team drilled over 1.5 miles into the seafloor, sampled microbes from mines and boreholes over 3 miles deep on land, and pulled together data from hundreds of sites scattered across the globe. The final estimate stunned even the researchers involved. Between 15 and 23 billion tons of carbon locked inside living cells, buried beneath our feet. To put that in perspective, scientists calculate the combined carbon mass of every single human being on Earth adds up to roughly 1/10 billion tons. That means this hidden layer of buried life outweighs all of humanity, combined by somewhere between 245 and 385 times over. Picture every person on the planet, all 8 billion of us, standing on one side of a massive scale. Now, picture the other side loaded with buried bacteria and other microscopic life, pulled from miles beneath the ocean floor and deep continental rock. That second side crashes down instantly, outweighing humanity by hundreds of times, and almost nobody on the surface has ever heard this world exists. Researchers estimate this entire hidden biosphere takes up roughly 2 billion cubic kilometers of space beneath the surface, nearly double the total volume of every ocean on Earth combined. And the record for how deep life has actually been found is staggering. Scientists have confirmed living organisms as deep as 3 miles beneath the continents, and even further beneath the ocean floor, in conditions crushed under pressure roughly 400 times what you feel standing at sea level. Down there, life looks nothing like life on the surface. Many of these organisms survive at such a crawling pace that scientists have taken to calling some of them barely alive, or almost zombie-like, existing in a strange in-between state, technically alive, but functioning at speeds slow enough to make a sloth look like a sprinter. One of the researchers involved described the challenge of studying this world perfectly. He compared exploring Earth's deep subsurface to exploring the Amazon rainforest, an entire ecosystem full of species and behaviors we are only beginning to understand, except this rainforest happens to be buried miles beneath solid rock instead of standing in open sunlight. And here's something that reshapes how scientists think about life on Earth's entire timeline. Researchers studying the deep history of our planet's biomass now believe that for roughly half the entire span of life's existence on Earth, stretching back well over 1 billion years, this deep, buried biosphere actually outweighed all the life living on the surface by as much as 10 times over. Surface life as the dominant form of life on this planet, the plants, animals, and eventually us, is actually a relatively recent development in Earth's long biological history. This changes how scientists think about life on other worlds too. If an entire hidden biosphere can thrive for billions of years, buried in total darkness, cut off from sunlight, deep inside a single rocky planet, then similar buried ecosystems could plausibly exist inside other worlds across the solar system, hidden beneath the surface of Mars, or sealed inside the icy shells of distant moons. An entire second biosphere, buried and mostly invisible, existing right alongside our own this whole time. And buried life isn't the only thing scientists have found frozen and locked away beneath the surface, waiting. Some of what's buried down there isn't alive at all, and it's raising an entirely different kind of concern. Scattered across the ocean floor, sitting under crushing pressure and near freezing cold, lies something that looks like packed snow, feels solid to the touch, and burns like fuel if you hold a lit match to it. Scientists call it methane hydrate, and people sometimes nickname it fire ice. It forms when methane gas becomes trapped inside a cage made of frozen water molecules, squeeze together under the specific combination of intense pressure and extreme cold found deep beneath the ocean floor. Bring a sample up to the surface, and it does something that looks almost unnatural. It fizzes, releasing trapped gas, and that gas can ignite instantly with nothing more than a spark held near it. Here's a number that puts the scale in perspective. A single cubic meter of this frozen material, roughly the size of a washing machine, can release up to 160 cubic meters of methane gas once it breaks down. That's enough gas to fill a small house from floor to ceiling, all packed inside a block barely bigger than an appliance. Scientists estimate that, combined, these frozen deposits scattered across ocean floors and buried under Arctic permafrost may hold more carbon than every reserve of coal, oil, and natural gas on Earth combined. That makes this frozen material one of the largest untapped stores of carbon anywhere on the planet, sitting largely unnoticed beneath the waves. Here's why scientists are watching it so closely. These deposits stay locked and stable only within a very specific window of cold temperature and crushing pressure. As ocean waters slowly warm, some of that stability starts to break down, and researchers are still working out exactly how much methane might escape as a result and how fast it could happen. Picture the ocean floor as an enormous frozen pantry, holding shelf after shelf of jars, each one sealed tight by cold and pressure. As the surrounding room slowly warms, some jars start to loosen. The question keeping scientists up at night isn't whether the jars can loosen, it's how many will loosen at once, and how much of what spills out actually makes it all the way up through miles of ocean water to reach the atmosphere. That last part turns out to be the trickiest piece of the puzzle. Researchers studying active methane plumes rising from the seafloor found that most of the escaping gas dissolves and gets consumed by microbes long before it ever reaches the surface. That's reassuring, in some ways. But a study off the coast of West Africa found methane traveling over 25 miles sideways underground before breaking through the seafloor in a completely different location, meaning these deposits don't always behave in the simple, predictable pattern scientists originally expected. A geologist who led that research put it directly. He said this discovery shows far larger volumes of methane may end up released from these deposits than anyone previously assumed, and researchers genuinely need to dig deeper to understand the true role these frozen stores play in our changing climate. So here sits one of the largest, least understood carbon reservoirs on the entire planet. Frozen solid, scattered across nearly every ocean on Earth, its future behavior still genuinely uncertain, even to the scientists studying it closest. And these frozen deposits aren't only found at the bottom of the sea. In the Arctic, similar buried gas has already started breaking loose on land, and when it does, it doesn't leak quietly, it explodes. In 2012, a helicopter pilot flying over Russia's Yamal Peninsula spotted something that shouldn't exist. A massive crater blasted straight into the frozen tundra, over 200 feet across, with no obvious cause, no meteor, no explosion reported by anyone nearby, just a sudden, violent hole punched into the ground in the middle of one of the most remote, frozen landscapes on Earth. Since then, researchers have identified around 8 of these giant craters scattered across Yamal and the nearby Gaidan Peninsula, some plunging over 150 feet deep. Local reindeer herders and gas workers in the region have reported hearing mysterious blasts echoing across the tundra for years, long before scientists ever confirmed exactly what was causing them. Here's the strange part. This phenomenon appears to happen only in this one specific corner of the Arctic. Nowhere in Canada, nowhere in Alaska, nowhere else across the entire circumpolar north. Despite permafrost covering vast stretches of the planet, that single detail puzzled researchers for over a decade, because it meant the explanation couldn't just be simple warming. Something specific to this one region had to be involved. Scientists eventually pieced together a chain reaction happening far below the surface. Picture a bottle of soda, shaken hard, then sealed tight under enormous pressure. As long as the cap stays on, nothing happens. But loosen that cap even slightly, and the pressure inside finds a way out, fast and violent. Beneath Yamal's permafrost, ancient marine sediment froze solid more than 40,000 years ago, trapping methane deep underground. Over time, natural gas reserves formed beneath that frozen layer, and the heat rising from those reserves slowly melted the permafrost from below, even while surface warming melted it from above. That left a pocket of highly pressurized gas, squeezed between a thinning ceiling of ice above and rising heat below. Researchers eventually found the final piece of the mechanism. As the permafrost warmed, meltwater seeped downward and interacted with underground salt deposits through a natural process called osmosis, causing a sudden spike in underground pressure. That spike was enough to crack the remaining frozen ceiling and trigger an explosive release of built-up gas, blasting a crater straight up through solid frozen ground. One researcher who worked on solving the mystery explained it clearly. She said, "Scientists already knew something was breaking down the frozen methane layer underground. What her team's research finally showed was the exact physical trigger causing that slow breakdown to suddenly turn explosive. This isn't a one-time event either. Expeditions to one particularly dramatic crater, now known as the Sayaka crater, found evidence that gas had built up steadily for years before finally erupting in a blast. So powerful witnesses reported seeing flames shoot from the newly formed hole. Scientists suspect there could be more of these craters than anyone has documented, since some may have quietly filled back in with water and sediment before researchers ever spotted them from the air. An entire hidden pattern of underground explosions, happening in one of the most remote places on the planet, discovered almost entirely by accident through pilots glancing down at exactly the right moment. The ground itself, frozen solid for tens of thousands of years, is starting to fight back against the heat pressing in on it from every direction. And Siberia's exploding permafrost isn't the only place on Earth where the ground beneath our feet is suddenly giving way without warning. On a September morning in 2025, outside a hospital in Bangkok, the street simply stopped existing. At just after 7 in the morning, a stretch of road collapsed without warning, swallowing an area roughly the size of a football field, plunging over 160 feet straight down. A police tow truck disappeared into the hole, along with several other vehicles. Buildings nearby had to be evacuated as engineers scrambled to check whether the ground beneath them was still stable. Officials later estimated repairs would take at least a year, and within days, the collapsed area had already grown wider as more ground gave way. Roughly a year earlier, in Kuala Lumpur, Malaysia, a sinkhole opened directly beneath a sidewalk on a busy street, nearly 30 feet deep, and a woman walking past in that exact moment vanished into it before anyone could react. Here's what makes sinkholes so unsettling. They can look, from the outside, like the ground simply decided to disappear with zero warning. But scientists are clear that the actual mechanics unfolding underground are slow, physical, and reasonably well understood, even if the final collapse itself feels sudden and violent. Picture a sturdy wooden floor sitting above a slowly hollowing out basement. For years, nothing on the floor looks any different. Underneath, though, water is quietly dissolving the support beams, or soil is steadily washing down into a growing gap below. The floor holds, right up until the exact moment it doesn't, and then it gives way all at once. Most sinkholes form because water dissolves soft underground rock, like limestone, gypsum, or salt deposits, carving out hidden cavities beneath the surface over months or years. Eventually, the thin layer of soil or pavement covering that hollowed-out space simply can't support its own weight anymore, and it drops. In the Bangkok case, investigators traced the trigger to soil flowing into a subway tunnel under construction nearby, worsened by heavy monsoon rains and cracks forming in the tunnel structure itself. In many cases worldwide, the same basic culprits show up again and again: heavy rainfall following a drought, excessive groundwater pumping that lowers the water table and removes support from rock above, aging or leaking underground pipes, slowly eroding the soil around them for years before anyone notices. What makes recent events feel especially alarming is the location. Sinkholes have long been associated with specific regions known for soft, porous ground, certain parts of Florida, certain regions of China, areas with long mining histories. But when a hole this size opens in the middle of a major capital city, outside a functioning hospital, with no prior history of ground collapse in that exact spot, it forces engineers to reconsider how thoroughly they actually understand what's happening beneath their own streets. Scientists have real tools to help predict these events before they happen: ground-penetrating radar, seismic surveys, satellite imagery capable of detecting subtle shifts in the surface, sometimes just millimeters at a time, months before a visible collapse. But these tools require someone to actually be watching the right spot at the right time, and the ground beneath a city holds far more hidden cavities than anyone has fully mapped. The surface we walk on every day, that feels so solid and permanent beneath our feet, is quietly hollowing out in places nobody has thought to check yet. Ground opening up beneath cities is unsettling enough on land, but Earth's ecosystems are also failing and recovering in ways that don't match any prediction, all the way from crumbling streets to living coral reefs stretched across entire oceans. Coral reefs are supposed to follow a predictable pattern when the ocean gets too hot. Heat stress builds. The coral expels the tiny algae living inside its tissue. The reef turns ghostly white, and depending on how long the heat lasts, the coral either slowly recovers its color or dies completely. That's the basic model scientists have relied on for decades. But real reefs, out in the actual ocean, keep refusing to follow that script. Researchers studying reefs around the world found something scientists did not fully predict. Some regions, like reefs across the Indian Ocean, devastated by a massive bleaching event back in 1998, staged a significant, wide-scale recovery over the following decades. Meanwhile, reefs in the Western Atlantic, hit by a string of smaller, less dramatic bleaching events, kept declining anyway, worn down gradually rather than wiped out all at once. Same basic threat, wildly different outcomes, and scientists are still working out exactly why identical stress produces such different results depending on where in the ocean you look. Picture two neighborhoods hit by the exact same storm. One rebuilds within a few years, stronger than before. The other never quite recovers, worn down bit by every smaller storm that follows. That's essentially the pattern researchers are seeing across the world's reefs, and it isn't fully explained by water temperature alone. Here's where it gets even stranger. Researchers studying reefs in northwestern Australia, in a region with some of the most extreme daily tide swings on Earth, expected these reefs to be tougher than most, since local coral there already deals with wild temperature shifts every single day just from the tides going in and out. And in some ways, that toughness held up. But scientists studying the region found something they didn't expect: coral sitting in the shallow tidal zone and coral sitting just slightly deeper in water that barely differs in temperature, recovered from the exact same bleaching event along completely different timelines. A difference of a few feet in depth, producing wildly different survival stories. Researchers analyzing recovery data across Australia's Great Barrier Reef found another twist. Nearly half of severely damaged reefs studied didn't recover along one smooth curve at all. Instead, they followed what scientists call a two-phase pattern, an unpredictable pause or stall partway through recovery before eventually resuming, if they resumed at all. Standard models built to predict reef recovery struggle to capture that kind of pause, because it doesn't follow the simple, steady curve those models assume. And there's a deeper problem layered on top of all this. Scientists calculated that the average gap between major bleaching events worldwide has shrunk to less than half of what it used to be. Reefs that once had 10 or 20 years to recover between major heat stress events now sometimes get only a handful of years, sometimes less, before the next wave of ocean heat arrives. It's like asking someone to fully heal from one injury while already bracing for the next one. over and over, with the recovery window shrinking every single time. What this all adds up to is a genuinely uncomfortable truth for scientists trying to protect these ecosystems. Reefs are not one single, uniform system responding predictably to warming water. They're a patchwork of wildly different survival stories, shaped by tiny differences in depth, tide, local ocean currents, and factors researchers are still identifying, and no single climate model has fully captured that complexity yet. Living reefs refusing to follow our predictions is one kind of mystery, but some of the biggest unanswered questions on this planet aren't found in ecosystems at all. They're buried in solid rock, holding more water than every ocean combined, hidden in a place almost nobody would ever think to look. 400 miles beneath your feet, sealed inside solid rock, scientists believe there may be an ocean holding as much water as every sea on Earth's surface combined. It sounds impossible. Rock and water aren't supposed to mix like that. But this isn't water sitting in some hidden underground cavern, sloshing around like a lake. It's water trapped at the molecular level, chemically bound inside the crystal structure of a mineral called ringwoodite, formed only under crushing pressure and heat, past 2,000 degrees Fahrenheit. Here's how scientists confirmed something this strange actually exists. In 2014, researchers studying a diamond pulled from the ground in Brazil noticed something unusual trapped inside it. A microscopic fragment of ringwoodite, a mineral that only forms under the extreme pressure found deep in Earth's mantle. It had hitched a ride to the surface millions of years ago, carried up inside a violent volcanic eruption, sealed safely inside the diamond the entire way, like a fly trapped in amber. When researchers analyzed that tiny fragment, they found something remarkable. About 1.5% of its weight came from water, not as liquid, but as hydrogen and oxygen atoms locked directly into the mineral's molecular framework. One geochemist involved in the discovery said, "This confirmed a massive amount of water is trapped in a very distinct layer deep inside our planet. Picture a sponge, squeezed under enormous pressure, holding water not in visible droplets you could shake out, but bound directly into the material itself, invisible unless you break it down at a molecular level." That's roughly the situation 400 miles beneath the surface, inside a layer of the mantle scientists call the transition zone. At first, scientists worried this single diamond might just be an unusual local pocket, not representative of the mantle as a whole. But researchers later found a second sample, another tiny fragment of water-rich ringwoodite, trapped inside a different diamond, confirming this wasn't just one strange coincidence. One mineral physicist involved explained the significance clearly. She said one sample could just be a local anomaly, but finding a second sample means this is likely widespread across the deep Earth, not confined to one small spot. If just 1% of the weight of the rock across this entire deep layer turns out to be water, calculations suggest that adds up to nearly 3 times the total volume of every ocean on Earth's surface combined, all of it locked invisibly inside solid rock, never touching sunlight, never forming a wave, never once reaching the surface as anything resembling the water we swim in. Scientists believe much of this deep water arrived through an ongoing process called subduction, where slabs of ancient ocean floor slowly sink deep into the mantle over millions of years, dragging trapped moisture down with them. Researchers now describe this deep layer almost like a graveyard for old ocean crust, quietly recycling water from Earth's surface into the depths of the planet over timescales far longer than human history. An entire hidden ocean, locked in stone, deeper than any drill has ever gone. And that buried water isn't the only massive, mysterious structure scientists have found sitting deep inside the Earth. There's something else down there too, sitting right at the edge of the core, roughly the size of an entire continent, and its twin sits on the exact opposite side of the planet. Nearly 1,800 miles beneath your feet, roughly halfway to the center of the Earth, 2 massive structures sit almost directly across the planet from each other. One rests beneath Africa, the other rests beneath the middle of the Pacific Ocean. Scientists gave them names, Tuzo and Jason, honoring two pioneers of deep Earth science. But naming these giant structures turned out to be far easier than actually explaining them. Each one stretches for thousands of miles across, roughly the size of a continent, rising as much as 1,000 kilometers above the boundary between Earth's molten core and its rocky mantle. Combined, these two structures cover something close to a third of the entire surface of Earth's core, a hidden layer wrapping around our planet's deepest interior like two enormous, mismatched patches sewn onto opposite sides of a globe. Nobody has ever touched either structure directly, and nobody ever will. Scientists know they exist because of how seismic waves behave when they pass through this region. Waves slow down noticeably as they cross these zones, roughly 1 to 3% slower than expected, revealing something down there that's physically different from the surrounding mantle rock. Denser, hotter, chemically distinct. Picture two enormous islands sitting at the bottom of an invisible ocean, made not of water but of solid rock flowing incredibly slowly over millions of years. From the surface of that ocean, you'd never see them directly. You'd only notice the way currents bend and swirl differently as they pass near each hidden landmass below. Here's where it gets stranger. These two structures aren't identical twins. Researchers studying their shape found the African structure rises roughly 1,000 kilometers higher above the core boundary than its Pacific counterpart, and appears to have a lower density, making it potentially less stable over long stretches of geological time. Meanwhile, detailed models tracking Earth's deep interior over the past billion years suggest the Pacific structure has been continuously fed by fresh material sinking down from ancient ocean crust, while the African structure formed from older material mixed together over a much longer stretch of time. Scientists still genuinely disagree on exactly what these buried giants are made of and how they first formed. One leading idea points to ancient slabs of ocean floor, dragged down into the deep mantle over hundreds of millions of years through the same process that recycles Earth's crust, eventually piling up into these two massive formations. Another idea suggests the material could be remnants from an ancient, deeply buried source, sitting largely undisturbed since the earliest chapters of Earth's history. One team of researchers studying the mystery put it plainly. They called these two blobs mysterious, noting that although scans clearly confirm the structures exist, very little else about them has been firmly established, largely because sending a probe or a scientist down to study them directly simply isn't possible with any technology that exists today. What makes these buried structures matter beyond pure curiosity is their apparent influence on the surface world far above them. Researchers have found that many of Earth's volcanic hotspots, both active today and traced through the geological past, cluster suspiciously close to the locations directly above these two deep formations, hinting that whatever sits down there may be quietly shaping volcanic activity happening thousands of miles above, at the very surface where we live. Two enormous, mysterious structures sitting almost perfectly opposite each other, deep inside the one planet we call home, and neither one has given up its secrets yet. And the deep Earth isn't done surprising us. Even Earth's spin itself, the steady rotation we've built our entire concept of time around, has quietly started behaving in ways nobody fully predicted. For most of Earth's history, one basic fact has held steady. The planet has been gradually losing speed. 100 million years ago, a full day on Earth only lasted about 23 hours, not 24, and that slowdown was caused by something scientists fully understood: the moon's gravity acting like a gentle brake, tugging on our oceans, gradually stealing a tiny bit of Earth's spin every single year. Then, starting around 2020, something unexpected happened. That gentle, centuries-long slowdown reversed. Earth started speeding up instead. The change is tiny, measured in milliseconds, less than the blink of an eye. But scientists using atomic clocks and orbiting satellites can measure Earth's rotation with incredible precision, and the numbers are unmistakable. On the 5th of July, 2024, Earth completed a full rotation, 1.66 milliseconds faster than the standard 24 hours, the shortest day ever recorded since scientists started using atomic clocks nearly 70 years ago. Then, in 2025, that record nearly broke again, multiple times, on specific dates tied to the Moon's position relative to Earth's equator. Picture an ice skater spinning slowly with her arms stretched wide, then pulling those arms in tight to her body, suddenly spinning faster. That's the basic physics behind why a planet's spin can speed up or slow down, a principle called conservation of angular momentum. When something shifts Earth's mass slightly closer to its spinning axis, even by a tiny amount, the whole planet spins just a little faster, the same way that skater does. Scientists do understand one piece of this puzzle clearly. Melting polar ice actually works the opposite way, spreading water out across the world's oceans and slowing Earth's spin down, similar to that same skater spreading her arms back out. A major study, published in the journal Nature, confirmed climate change and melting ice caps have been measurably dragging on Earth's rotation in recent decades. So if melting ice is slowing the planet down, what's causing this sudden burst of speeding up instead? That's the part that has genuinely stumped researchers. One geophysicist involved in studying the trend called it an unprecedented situation, notable enough that scientists are now seriously discussing something that has never happened before in the history of modern timekeeping: a negative leap second, subtracting a second from global clocks instead of adding one, possibly as soon as 2029. Some researchers suspect the answer might be hiding in the same deep churning core responsible for Earth's magnetic field and its wandering magnetic pole. Shifts in the flow of molten metal deep inside the planet could subtly redistribute mass, speeding up the crust above, even while ice continues melting and technically working to slow things down. But that connection remains a theory, not a confirmed cause, and scientists genuinely don't have a complete explanation yet. Here's the part that should make you pause. Every satellite orbiting Earth, every GPS system guiding your phone, every piece of global technology depends on precisely knowing how fast this planet spins. And right now, the honest answer from the scientists studying it closest is that nobody fully knows why the ground beneath your feet just started moving a little bit faster. This isn't the only place where Earth's spin has been quietly shifting in ways scientists are still working to fully explain. There's another subtle wobble hiding in the way our planet turns, one connected to something happening on the surface itself. For over a century, scientists have known that Earth doesn't spin perfectly straight. It wobbles, ever so slightly, tracing out a small, uneven circle as it turns, a motion astronomers call polar motion. And a piece of that wobble carries a name from over 100 years ago, the Chandler Wobble, discovered in 1891 by an amateur astronomer who noticed the stars seemed just slightly off from where a perfectly stable Earth's axis should place them. For decades, nobody could fully explain why this specific wobble existed at all. Then, more recently, scientists made a discovery that connects this ancient astronomical puzzle to something happening right now, driven directly by human activity. Picture spinning a basketball perfectly balanced on your fingertip. Add a small amount of extra weight to one spot on the ball, or remove weight from another spot, and the ball starts to wobble unevenly as it spins. Earth works the same way. Move enough mass around on the surface, water especially, and the entire planet's spin axis responds, shifting by a small but very real amount. Here's where humanity enters the picture. Researchers studying decades of satellite data found that humans have pumped so much groundwater out of the ground for drinking and irrigation, water that used to sit locked beneath the continents, that its redistribution into rivers and oceans has measurably nudged Earth's rotational axis. The planet's pole has drifted roughly 9 centimeters a year in the direction of Iceland, and when scientists built models accounting for melting ice sheets and new dam construction, they still couldn't fully explain the wobble. Only after adding the effect of pumped groundwater did the numbers finally line up. One geophysicist not involved in the research called the discovery mind-boggling. He said the very way the planet wobbles is being shaped by our own activities. And the story keeps getting stranger. A study published in September of 2025 found that this same Chandler wobble, the exact one discovered back in 1891, nearly vanished entirely after 2015. Scientists traced the sudden disappearance to a massive climate event, a powerful La Niña that shifted huge volumes of water and air pressure around the globe, disrupting the wobble's usual rhythm in a way researchers are still working to fully model. Think of it like a spinning top that has kept a steady, familiar wobble for over a century, then suddenly and mysteriously smoothed out, almost stopping its characteristic rocking motion, triggered by shifts in weather patterns thousands of miles away. This matters far beyond scientific curiosity. Every navigation satellite, every precise timing system, every astronomical reference point used by GPS depends on accurately tracking exactly how Earth's axis moves. A sudden, unexplained shift in that wobble ripples outward into every piece of technology, relying on knowing precisely where the planet's poles actually are at any given moment. Scientists now use this wobble almost like a diagnostic tool, a way of detecting how much water humanity is moving around the globe, even in regions where measuring groundwater directly is nearly impossible. The planet's spin has effectively become an enormous, extremely sensitive scale, capable of registering the combined weight of billions of gallons of water shifted by human hands, one subtle wobble at a time. Earth's spin, its magnetic field, its wandering pole, its core spinning at its own independent pace. Every single one of these systems is connected, deep beneath the surface, in ways scientists are only beginning to map. And there's one more piece of this puzzle still to explore. Back at the very place where this story began, the crack in Earth's shield. Somewhere out past normal, ordinary geology, sits a fact most people never learn in school. Earth's entire magnetic field, north and south, has completely swapped places hundreds of times throughout our planet's history, and the crack over South America might be an early whisper of this happening again. Scientists reading the magnetic record locked inside ancient volcanic rock have found evidence of at least 180 full pole reversals over the past 83 million years alone, and several hundred more stretching back 160 million years before that. During certain especially chaotic stretches of Earth's history, the poles flipped as often as 26 times every million years, more than 5 times the pace scientists see over just the last 10 million years. Here's how scientists actually know this happened. As molten rock rises up along the ocean floor and slowly cools into solid stone, tiny magnetic particles inside it lock into place, permanently aligned with whatever direction Earth's magnetic field was pointing at that exact moment, like a compass needle frozen solid in time. Rock formed today records today's magnetic direction. Rock formed a million years ago records whatever direction the poles were pointing back then. Layer by layer, scientists can read this frozen record stretching back tens of millions of years, like flipping through the pages of an enormous stone notebook. The last full reversal happened roughly 780,000 years ago, long before modern humans existed. And here's something that recently surprised researchers even further. A team studying ancient sediment layers found this last reversal did not happen quickly. It dragged on for at least 22,000 years, several times longer than scientists previously assumed, weakening, partially shifting, briefly stabilizing, then finally settling into the orientation we know today. Picture a slow, staggering U-turn instead of a sudden, sharp swerve. That's roughly how a magnetic reversal plays out. Not a sudden flip overnight, but a chaotic, multi-thousand-year process, with the field weakening dramatically, wobbling unpredictably, and sometimes even developing multiple weak poles at odd locations before finally settling into its new direction. Since that last full reversal, scientists have identified around 15 partial attempts, moments when the field weakened dramatically and started drifting toward a flip, without ever fully completing one, called excursions. The most recent excursion happened around 40,000 years ago, and right now, researchers tracking the field's overall strength have found it has lost roughly 30% of its intensity over just the last 3,000 years, a significant, measurable decline. One researcher studying this decline predicted the field could weaken dramatically over the coming centuries or millennia. Scientists are careful to stress this doesn't mean sudden catastrophe. A weakening field, even a full reversal, has happened dozens of times throughout human evolutionary history, and life on Earth has survived every single one. But here's the connection worth sitting with. The crack in Earth's shield over South America, the splitting anomaly, the weakening field intensity measured by satellites for over a decade now, these aren't separate, disconnected mysteries. They may be the opening pages of the exact same ancient, recurring story. A magnetic field slowly losing strength, exactly the way it has hundreds of times before, in a process that plays out over thousands of years, largely invisible to anyone living through it. An entire planet, breathing and shifting on timescales longer than human civilization itself. And every single mystery in this story connects back to that same restless, living Earth beneath our feet. Every single continent on Earth is drifting, right now, at roughly the speed your fingernails grow. And after more than 60 years of studying this motion, scientists still argue about the exact force actually driving it. This might sound surprising. Plate tectonics is one of the most confirmed theories in all of Earth science. The framework explaining earthquakes, volcanoes, mountain ranges, and ocean basins. Nobody doubts the plates move. What remains genuinely unsettled is a more specific question, buried underneath the basic theory. What exactly pulls and pushes them? For decades, the leading explanation was mantle convection. Picture a pot of thick soup simmering on a stove. As heat rises from the bottom, hot soup slowly circulates upward, spreads out, cools, and sinks back down, forming a slow, continuous loop. Early geologists imagined something similar happening inside Earth's mantle. Giant, slow-moving currents of hot rock, dragging the plates above them along like conveyor belts riding on top of that circulating soup. That explanation, once considered fairly settled, has come under serious challenge in recent decades. Scientists studying seismic data noticed something that didn't fit cleanly. Some tectonic plates move significantly faster than the mantle currents supposedly dragging them along beneath. If a conveyor belt were truly driving the plates from below, the plates shouldn't be able to outrun their own conveyor belt. And yet, in several cases, that's exactly what the data seemed to show. That mismatch pushed many researchers toward a different explanation entirely. Instead of the mantle actively dragging plates along from underneath, some scientists now believe the plates themselves are the primary drivers, pulled largely by their own weight. As old, cold, dense sections of ocean floor sink downward into the mantle at subduction zones, that sinking slab tugs the rest of the connected plate along behind it, almost like a heavy anchor chain pulling a boat forward as it drops toward the seafloor. Scientists call this slab pull, and many now consider it the single most powerful force at work. A second force, called ridge push, adds another piece to the puzzle. At mid-ocean ridges, where fresh magma rises up and cools into new seafloor, that newly formed rock sits slightly elevated and slides gradually downhill under its own gravity, nudging the plate forward from the opposite direction. Here's the honest, current scientific position on this question. Researchers increasingly believe both mantle convection and the plate's own weight are deeply intertwined, not separate competing explanations, but two halves of one single, self-organizing system. Recent three-dimensional models suggest the relationship between plates and the mantle beneath them actually shifts over enormous stretches of geological time, sometimes acting more like the mantle drags the plates, sometimes acting more like the plates drag the mantle. One research team studying this relationship concluded the old question might genuinely be framed the wrong way. Instead of asking whether the mantle drives the plates or the plates drive themselves, The more accurate question may be how that balance of power shifts back and forth across hundreds of millions of years. So, the ground you're standing on, slowly drifting across the surface of this planet, is being moved by a force scientists still can't fully pin down, even after 6 decades of dedicated research. It's a reminder that even our most trusted, well-established theories about this planet still have real, unresolved edges. And speaking of unresolved edges, there's a category of Earth's mysteries that doesn't fit into rock, water, or magnetic fields at all. It lives in something far stranger, buried in one of the tiniest, most complex objects known to science. The human brain itself, wired directly into how we experience this entire planet. Every mystery covered so far has lived outside of you, buried in rock, hidden in ice, floating above storms. But the strangest, most stubborn mystery on this entire planet might be sitting 3 pounds heavy, right behind your own eyes, running the whole time you've been listening to this. Scientists can map your brain in incredible detail. They can trace exactly which neurons fire when you see the color red, which regions light up when you feel fear, which pathways activate when you recognize a familiar face. Modern neuroscience has gotten remarkably good at answering the how thoughts form, how memories get stored, how signals travel from your eyes to your brain in a fraction of a second. But there's a deeper question buried underneath all of that, one modern science still cannot answer. Why does any of it feel like something at all? A philosopher gave this question a name back in 1995, calling it the hard problem of consciousness. Here's the distinction that makes it so tricky. Scientists call questions about brain mechanics the easy problems, not because they're actually simple, but because researchers already understand the basic approach needed to eventually solve them, even if the details take decades of careful work. The hard problem is different. It isn't about mapping which neurons fire. It's about explaining why that firing is accompanied by an inner experience at all, instead of simply happening in the dark, like a machine running its programming with nobody home to notice. Picture watching a firework explode in the night sky. Scientists can fully explain the chemistry behind the colors, the physics behind the explosion, the exact wavelength of light hitting your eyes. But none of that chemistry explains why you experience the burst of red and gold as beautiful, why it feels like something specific to witness it, rather than simply registering as data with nobody actually seeing it happen. This gap between the physical mechanics and the felt experience is sometimes called qualia, the specific, personal quality of an experience, like the particular redness of red or the exact sourness of biting into a lemon. You can describe wavelengths and taste receptors in perfect scientific detail and still never fully capture what it's actually like to be the one seeing that color or tasting that lemon. Even leading neuroscientists studying this question today admit real limitations remain. One prominent researcher recently spoke about major gaps still standing in our current understanding, gaps that persist even after decades of remarkable advances in brain imaging and neuroscience. Scientists have proposed dozens of competing theories trying to bridge this gap, ranging from ideas rooted purely in brain biology to far more radical proposals suggesting consciousness might connect to something more fundamental about the nature of reality itself. None of these theories has managed to fully close the gap yet, and some researchers openly wonder whether it can ever be fully closed using the tools of science as we currently understand them. Here's what makes this mystery different from every other one in this story. The magnetic field, the wobbling pole, the buried water inside rock, all of those are mysteries about the world around you. This one is a mystery about the very fact that you're able to experience any of it at all, right now, as these words reach your ears. And that brings us to the deepest connection running through everything you've just heard. Every single mystery you've just heard traces back to one simple, almost uncomfortable truth. This planet has never stopped moving. Think back to where this story started. A hole in Earth's magnetic shield, growing wider, splitting into two. That crack traces down nearly 2,000 miles, straight to a buried structure the size of a continent, warping the field from below. That structure sits near a core, doing something scientists barely understand. A ball of iron the size of the moon, slowing down, reversing direction, following some hidden 70-year rhythm nobody fully predicted. That same churning core builds the field responsible for the pole now sprinting across the Arctic towards Siberia, fast enough to force navigation systems to rewrite their maps years ahead of schedule. And that field, the one protecting every satellite, every phone, every GPS signal you use, has flipped completely, hundreds of times. Throughout Earth's long history, each flip a slow, chaotic, multi-thousand-year event, unfolding largely unnoticed by whatever was alive to witness it. Picture all of this laid out like a single, enormous machine, with every part connected to every other part by threads running thousands of miles deep. Pull one thread, the core's rotation, and another moves, the pole's position. Pull that thread, and a third one shifts, the strength of the shield protecting us from space. Nothing on this list has ever really been separate. It's all one restless, breathing system, and we're standing on its surface, mostly unaware of how much of it is shifting beneath our feet at any given moment. The hum beneath your feet, ringing constantly, announcing the secret birth of a new volcano before anyone even knew to look. The reefs in the ocean, refusing to follow the tidy predictions of any single climate model, recovering in one place, collapsing in another, shaped by tiny differences scientists are still working to untangle. The ground in Siberia, exploding upward from pressure building for years in total silence. The ground in Bangkok, giving way in an instant after months of quiet, invisible erosion nobody thought to check. Even the water itself refuses to stay where the textbooks put it. An entire hidden ocean, locked inside solid rock 400 miles beneath the surface. More water than every sea combined, moving as slowly as the rock that holds it. And an entire second biosphere, buried in darkness, outweighing every human being on Earth by hundreds of times over, existing on a timescale where a single generation can outlast entire human civilizations. Here's the thing worth sitting with. None of this was ancient history. The fireballs over Houston and Ohio happened this year. The reversing magnetic north was confirmed this year. The vanishing Chandler wobble, the splitting anomaly, the backward spinning core, every single one of these discoveries came from scientists working right now using satellites and instruments more precise than anything that existed even a decade ago. We used to think discovery meant looking outward, toward distant stars and other planets. But some of the strangest, most genuinely unexplained places in the entire universe might be sitting right here, buried beneath our own 2 feet, humming quietly, waiting for someone with the right instrument and the right question to finally listen closely enough. This planet has been changing since the day it formed, and it has no intention of stopping now. Stand in the right part of northern Canada, and something strange happens to your own weight. You get very slightly lighter, not because of diet or exercise, but because the actual pull of gravity beneath your feet is measurably weaker than almost anywhere else on Earth. Scientists first discovered this in the 1960s, while mapping gravity across the entire planet. Around the Hudson Bay region, instruments kept detecting something unexpected. Gravity there measured noticeably lower than the surrounding areas. A real, physical dip in the force pulling everything on the surface downward, sensitive enough to detect, though nowhere near strong enough for anyone standing there to actually feel the difference themselves. Here's a way to picture it. Press your finger gently into a spot on a rising loaf of bread dough. The dough dips down right where you pressed, and even after you lift your finger away, it takes time to spring back to its original shape. Something remarkably similar happened to the crust beneath Hudson Bay, except the finger pressing down was an ice sheet nearly 2.5 miles thick, and it took 20,000 years to melt away. That ice sheet, called the Laurentide Ice Sheet, once buried most of Canada under an almost unimaginable weight of frozen water. All that mass pushed the crust beneath it downward, compressing it like a mattress under a heavy weight. When the ice finally melted away around 10,000 years ago, The crust should have slowly bounced back to its original shape, and it has been bouncing back, rising roughly half an inch every year. But scientists calculate it will take another 300,000 years before it fully returns to where it started. Right now, in the present day, Hudson Bay still sits in a shallow dent left behind by ice that disappeared 10 millennia ago, and that missing bit of crust means slightly less mass and therefore slightly less gravity, pulling down on anything standing above it. For decades, that explanation alone didn't fully satisfy scientists. The math didn't quite add up, so researchers went looking for a second contributing factor and found one deep beneath the surface. Slow, churning currents in the mantle appear to be actively dragging down on the crust in this exact same region, working alongside the leftover dent from the ice sheet rather than against it. It took satellite data, gathered decades after the anomaly was first discovered, to finally confirm both explanations were correct at once. Researchers found that the lingering effects of the ice sheet account for roughly a quarter to nearly half of the anomaly, with deep mantle convection responsible for the remainder. Two separate forces, one from the recent icy past, one from the deep, slow churn of the present, both pulling in the same direction, both still measurably weakening gravity across this one stretch of Canada today. What makes this genuinely remarkable is the timeline. An ice age that ended 10,000 years ago is still actively shaping the force of gravity across a stretch of the modern world. A slow, physical echo of a climate event so ancient it predates written history, still measurably altering the physics of the ground beneath people living there today. Gravity itself, the most basic, unchanging force most of us take completely for granted, turns out to have its own soft spots and lingering scars, carved by events that ended long before any human wrote them down. And there's one more piece to this story, tied to something scientists recently discovered lurking not beneath Canada, but beneath one of the most watched patches of the Pacific Ocean on Earth. Beneath the geysers and colorful hot springs of Yellowstone National Park sits one of the most closely watched volcanic systems on Earth, and scientists just found the exact reason it hasn't erupted in hundreds of thousands of years. For decades, researchers pictured Yellowstone's magma system as a single, giant chamber of liquid rock, slowly filling with pressure like a balloon, destined to eventually burst. That mental picture turned out to be wrong. A team of researchers from 4 different universities finally mapped the very top of Yellowstone's magma reservoir in sharp detail, and what they found wasn't a fragile, thinning ceiling about to crack. It was a thick, gas-rich natural lid, sitting roughly 2.5 miles beneath the northeastern section of the caldera, actively holding the system in check. To find it, researchers drove a 53,000-pound truck across the ground, sending gentle, controlled vibrations deep underground, then carefully recording the echoes bouncing back, essentially giving Yellowstone an enormous ultrasound. What emerged was a picture nobody had captured this clearly before. Picture a pot of soup simmering gently on very low heat, with a tight lid clamped firmly on top. Steam builds up underneath, but instead of exploding the lid off, the pressure stays balanced, contained, held in a stable, simmering state. That's roughly the situation researchers found underground. Beneath this newly discovered lid sits a strange mixture of superheated, pressurized water, existing in a state where the line between liquid and gas essentially disappears, mixed together with a type of magma that tends to erupt violently if it's ever given the chance to escape. One member of the research team described the pressure levels found at the top of this reservoir as well below what's typically needed to trigger an eruption, meaning this famous, feared supervolcano currently sits in a genuine, measurable state of calm. But solving one mystery at Yellowstone immediately opened up another. If the traditional picture of one giant magma chamber was wrong, what was actually feeding this system in the first place? A separate team of researchers, publishing a completely different study just months later, tackled that exact question, and their answer overturned decades of assumptions. For years, Scientists believed Yellowstone was powered by a narrow plume of superheated rock, rising in a relatively straight line from deep near Earth's core, like a single lit candle stuck straight up through the mantle. The new research suggests something far stranger. Instead of one narrow plume, researchers found evidence of what they're calling a mantle wind, a broad, sideways moving current of hot rock pushed by the motion of Earth's tectonic plates far above, generating magma much closer to the surface than anyone previously assumed. Rather than one deep, isolated chamber, magma appears distributed across an enormous mush zone, a vast region of partially melted rock stretching through much of the crust itself. This complete change in understanding matters immensely for monitoring. Current instruments were designed specifically to detect a deep, singular plume, and researchers are now scrambling to adapt their equipment to properly track this newly discovered, much broader system instead. An enormous, world-famous supervolcano, studied constantly for decades by thousands of scientists and researchers, only just now finally worked out both what's holding it stable and what's actually feeding it from below. And Yellowstone's hidden lid isn't the only recent discovery reshaping what scientists thought they understood about volcanic systems buried deep beneath continents. Deep beneath the surface of the Atlantic Ocean, an enormous system of moving water works like a conveyor belt, carrying warm water north and cold water south, quietly shaping the climate of entire continents. Scientists call it the Atlantic Meridional Overturning Circulation, and mounting evidence suggests it's slowing down, though researchers are still working out exactly how fast and exactly what happens if it keeps weakening. Picture a massive underwater river, invisible from the surface, stretching the entire length of the Atlantic Ocean. Warm water flows north along the surface, all the way up toward Greenland and Iceland. Once it arrives in the cold Arctic air, that warm water cools, becomes denser, and sinks, then travels back south along the ocean floor, completing a giant, slow-motion loop that takes roughly 1,000 years to finish a single cycle. This circulation is a major reason why parts of Western Europe stay milder than other places at similar latitudes, since it constantly ferries warmth north from the tropics. Here's the concern. As Greenland's ice sheet melts, it dumps enormous volumes of fresh, less dense water into the North Atlantic, right at the exact spot where this circulation depends on water becoming heavy and salty enough to sink. Fresh water resists sinking. Pour too much of it into the system, and the entire engine driving this ocean conveyor belt can start to stall, the same way pouring oil into water disrupts a current that depends on density differences to keep moving. Scientists studying centuries of ocean data have found genuine signs of weakening, though the exact numbers remain hotly debated within the scientific community itself. Some studies suggest this circulation has already slowed by something like 15% since the mid-20th century. Others urge caution, pointing out that direct, continuous measurements of the full system have only existed for a couple of decades, making it genuinely difficult to separate a long-term decline from natural, shorter-term fluctuation. What makes this genuinely uncertain, rather than settled, is the disagreement among climate models themselves about exactly how close this system might be to a tipping point, a threshold beyond which the circulation could shift into a dramatically weaker state, relatively abruptly, rather than declining gradually over centuries. Researchers studying this question openly acknowledge the science isn't fully resolved. Some models predict a slow, gradual decline stretching across hundreds of years. Others suggest the possibility of a much faster, more disruptive shift, though pinpointing exactly when, or if, that shift might happen remains one of the genuinely open questions in modern climate science. If this circulation did weaken dramatically, the consequences would ripple far beyond ocean temperatures, shifting rainfall patterns across the tropics, colder winters across parts of Western Europe, even as the rest of the planet continues warming. Changes to fish populations and marine ecosystems that have depended on this circulation's steady rhythm for thousands of years. An entire ocean's worth of moving water, quietly shaping weather and climate patterns across multiple continents. and scientists are still working, in real time, to understand exactly how much it's changing and how close it might be to shifting into something genuinely different. Ocean currents slowing down is one kind of hidden shift, but sometimes the biggest mysteries aren't happening slowly at all. Sometimes an entire patch of ocean changes almost overnight and stays that way for years. In October of 2013, a strange pool of unusually warm water quietly appeared off the coast of Alaska, and by the time it finally faded, scientists had watched an entire ecosystem transform in front of them. Researchers nicknamed it the blob, and at first, nobody fully understood why it was happening or why it refused to go away. A persistent zone of high pressure settled over the northeastern Pacific and stayed there, month after month, weakening the winds that normally stir and cool the ocean surface. Without those winds, heat that would usually get churned away instead built up and lingered, spreading south along the coast until, by the summer of 2014, warm water stretched over 1,000 miles wide, from Alaska all the way down to Mexico, in places reaching temperatures up to 7 degrees Fahrenheit above normal. Picture a lid clamped over a pot of water on the stove, trapping heat that would normally escape into the air above. That's roughly what happened over the Pacific. An atmospheric lid holding heat in place for months, then years, far longer than any similar event scientists had ever recorded. Here's what made the blob so scientifically strange. Researchers still genuinely debate what actually caused it in the first place, and more importantly, what caused it to last so long. Some studies point to broader ocean warming as the trigger for that unusual atmospheric ridge. Other research suggests the reverse, that the ridge came first and triggered the warming, with the two effects then feeding back into each other, each one reinforcing the other in a loop that let the whole event drag on for nearly 3 full years, an outcome nobody fully predicted or explained in advance. The ecological impact was staggering to witness in real time. A research scientist monitoring waters off Oregon described pulling up sampling nets that summer and immediately knowing something had gone deeply wrong. Small, shrimp-like creatures that fish and seabirds depend on for food nearly vanished from the nets. In their place, scientists found gelatinous, tube-shaped animals called pyrosomes, translucent creatures that had never before been documented in these waters, competing directly with native species for food while offering far less nutritional value to anything trying to eat them. The disruption rippled outward through nearly the entire food web at once. Sea lion pups washed ashore, starving in unprecedented numbers. Thousands of seabirds died. Toxic algae blooms stretched unusually long, contaminating shellfish along the entire west coast and delaying commercial fishing seasons for months. Kelp forests, stripped bare as warming waters triggered explosive growth in sea urchin populations, transformed into what scientists now call urchin barrens, barren underwater landscapes that in some areas still haven't recovered years later. One research team studying the event, watching an ecosystem shift so dramatically in real time, asked a question in their published paper that genuinely unsettled other scientists reading it. They wondered aloud whether this particular ecosystem had crossed a tipping point it might never fully return from. And here's the part that should give you pause. In 2026, ocean temperatures off the west coast began climbing again, rapidly, across the exact same stretch of Pacific coastline, with researchers openly warning that conditions eerily similar to the original blob may be returning on a scale that could rival or even exceed what happened over a decade ago. An entire coastal ecosystem disrupted almost overnight by a single, poorly understood atmospheric event, some of its consequences still visible more than 10 years later, and quite possibly returning again right now, while scientists still don't have a complete answer for why it happened the first time. And this pattern, something in the ocean shifting suddenly and reshaping everything around it, connects to one final piece of this story, buried far beneath the waves, in the frozen record of Earth's own deep past. Somewhere in Earth's deep past sits a stretch of time so strange, so stubbornly uneventful, that scientists actually nicknamed it the boring billion. And the more closely researchers examine it, the less boring and the more genuinely mysterious it turns out to be. Here's the basic outline. Roughly 1.8 billion years ago, after an early burst of dramatic change on young Earth, oceans forming, life first appearing, oxygen slowly building in the atmosphere, everything suddenly, inexplicably slowed down. Climate stabilized, oxygen levels leveled off. Life kept existing, but barely evolved, remaining little more than a thin layer of slime and simple single-celled organisms for an entire billion years. Then, starting around 800 million years ago, everything changed again. Massive glaciations swept across the planet. Complex life exploded into new forms. Eventually, roughly 520 million years ago, an extraordinary burst of evolutionary diversity known as the Cambrian explosion produced the ancestors of nearly every major animal group alive today. Picture a marathon runner who sprints out of the starting gate, pushes hard for the first mile, and then, for reasons nobody fully understands, settles into an almost motionless jog for the next 23 miles straight, before suddenly breaking into a full sprint again right before the finish line. That strange, drawn-out middle stretch is essentially what happened across a full third of Earth's entire history, and scientists have spent decades debating exactly what caused that billion-year lull. One leading theory points toward Earth's own interior. Researchers studying the geologic record found this period lined up closely with an era of unusually stable, stagnant tectonic activity, plates barely shifting compared to earlier and later eras. One geologist compared it to turning down a stove burner. As Earth's interior gradually cooled during this stretch, the surface above thickened and stabilized, slowing the normal churn of continents drifting, colliding, and splitting apart, the very engine that normally drives dramatic environmental change. A separate research team took an entirely different angle, digging directly into ancient rock samples for clues about ocean chemistry. Analyzing thousands of samples spanning 3.5 billion years, they discovered something unexpected. During this exact stretch of time, the concentration of trace metals dissolved in the ocean, the same metals like copper, zinc, and cobalt that living cells depend on for critical biological functions, dropped significantly. Their conclusion suggested life wasn't simply idle during this period. It may have been genuinely starved of raw materials it needed to evolve further. More recent research has complicated the picture even further. Scientists studying fossilized single-celled marine organisms found that early complex life did emerge right at the start of this supposedly boring stretch, only to see its diversity suddenly and dramatically collapse partway through, hinting at environmental conditions more turbulent and dynamic than the boring nickname suggests. Other researchers have proposed the breakup of an ancient supercontinent partway through this era may have carved out crucial new shallow marine habitats, quietly setting the stage for the explosive diversification that would eventually follow. So, which explanation is correct? Cooling tectonics, starved ocean chemistry, hidden bursts of evolutionary activity, later erased by later collapse. The honest answer is that scientists still genuinely disagree, and the deeper researchers dig into this billion-year stretch, the more it looks less like an empty gap in Earth's history, and more like a slow, patient build-up, quietly assembling every ingredient needed for the explosion of life that eventually followed. An entire billion years, nearly a quarter of Earth's total lifespan, and scientists are still working out exactly what was actually happening during that time, hidden in plain sight, buried in the oldest rocks on the planet. For years, one of the most beloved ideas about nature spread across books, documentaries, and blockbuster movies. Trees, connected underground by vast networks of fungus, quietly sharing food, water, and even warning messages with each other, like a hidden internet running beneath every forest floor. It's a beautiful image, and recently, a growing number of scientists have started raising a genuinely uncomfortable question: how much of it is actually proven? The idea traces back to a 1997 study when a Canadian forest ecologist demonstrated that carbon could move between trees through underground fungal connections called mycorrhizal networks. That single finding exploded into a much bigger cultural idea, popularized through best-selling books that describe trees as intelligent, caring beings, sending nutrients to struggling neighbors and protecting their own seedlings the way a parent protects a child. The concept found its way into blockbuster films and hit television shows, and became one of those rare scientific ideas nearly everyone has heard of, even people who know almost nothing else about trees or forests. Here's what the underlying biology genuinely does support. Nearly every tree on Earth forms a real, well-documented partnership with fungi living in and around its roots. The tree provides the fungus with sugars produced through photosynthesis, sometimes giving away as much as half of everything it makes through that process. In exchange, the fungus delivers water and nutrients pulled from the surrounding soil. These fungal threads genuinely do form enormous, sprawling networks underground, connecting to multiple trees at once, sometimes even linking different species together. Where the story gets shakier is the leap from that basic partnership to the idea of trees deliberately communicating, sharing resources with intention, or nurturing their own offspring through these networks. A major review published in 2024, examining 28 separate field experiments testing these claims, found only 5 that even hinted at nutrient transfer happening between trees at all, and not a single one demonstrated any actual benefit to the seedlings supposedly receiving help. Picture a phone line that technically connects 2 houses, wired and functional, but with no actual evidence anyone has ever picked up the receiver and had a conversation. That's roughly the gap researchers are pointing to. The physical network is real, proof that trees are actively using it to intentionally communicate or share resources remains, by the researchers' own admission, unresolved. One team of researchers went further, tracing how the scientific narrative itself had drifted over time, studying papers published in 2022 that cited older, foundational research on these fungal networks. They found fewer than half accurately represented what those original studies had actually shown. A widely cited 2009 study, for example, gets referenced constantly as evidence trees transfer nutrients between each other, despite the fact that the original research never actually tested nutrient transfer at all. One of the researchers involved compared the pattern to a long game of telephone, distortions compounding paper after paper, drifting further and further from the original evidence with each retelling. A forest ecologist studying the controversy summed up the current scientific standard bluntly. "Extraordinary claims," he said, "require extraordinary evidence, and so far, that evidence simply hasn't fully arrived." None of this means the Wood Wide Web is pure fiction. The fungal networks are real, the underlying partnerships are real, and researchers haven't ruled out that some form of resource sharing does occur. What remains genuinely unresolved is exactly how intentional, how significant, and how communicative these connections actually are. A case where one of nature's most charming, widely believed stories may have outpaced the science supporting it, and scientists are now working carefully to figure out exactly where the real evidence ends and the beautiful narrative begins. Every single mystery in this story points back to the same uncomfortable, thrilling truth. Earth was never finished. It was never a solved planet, quietly waiting for us to arrive and understand it completely. It has been changing this entire time, in ways large and small, above us and beneath us, and in most cases, we only noticed by accident. Think about how many of these discoveries started with someone simply paying attention at the right moment. A camera left running by scientists testing equipment for something else entirely, accidentally catching the first sprite ever recorded. A helicopter pilot glancing down at exactly the right second, spotting a crater blasted into frozen tundra that had exploded without a single witness. A diamond, pulled from the ground in Brazil for entirely unrelated reasons, quietly carrying proof of an ocean's worth of water hidden inside solid rock for millions of years. Astronauts on the International Space Station, glancing out a window during a quiet moment, capturing lightning that shoots towards space instead of down toward the ground. None of this was ancient history playing out in a textbook. The magnetic pole crossing into new Arctic territory, the inner core reversing its spin, the fireballs exploding over Houston and Ohio, the vanishing wobble in Earth's rotation, the Pacific blob possibly returning. Every single one of these came from research published within the last few years, some within the last few months. This planet is not a museum piece. It is an active, breathing system, and scientists are racing in real time just to keep up with what it's doing next. Here's what ties every chapter of this story together. Nothing on this list happened in isolation. The crack in the magnetic shield traces down to a buried structure the size of a continent. That structure sits above a core doing something nobody predicted. That same churning core drives the pole now racing toward Siberia and connects to a field that has flipped hundreds of times throughout our planet's long history. The hum beneath your feet, the water locked in solid rock, the reefs refusing to follow any single model, the ground exploding in Siberia and collapsing in Bangkok. All of it is one interconnected, restless system, and we are simply standing on top of it, mostly unaware of how much is shifting beneath our feet at any given moment. Even the story of the forest floor, one of the most beloved, comforting ideas about nature in recent memory, turned out to be more complicated and more uncertain than the popular version anyone has heard. That uncertainty isn't a failure of science. It's exactly how real science works, constantly checking itself, correcting course, willing to say we don't fully know yet, even when the alternative story is more comforting to believe. That's really what this entire journey has been about. Not a planet full of solved puzzles, but a planet still actively writing its own story. One satellite reading, one seismic wave, one accidental photograph at a time. The ground beneath your feet right now is part of a system billions of years in the making, still shifting, still humming, still surprising. The very scientists who have spent their entire careers trying to understand it. Earth has never stopped changing. And the truth is, we're only just beginning to notice how much we still don't know.